Hello, welcome to the third video of NumPy. Nerdine Mohammed. In the last video, we talked about data manipulation in NumPy. From this manipulation is stacking, which is stacking ND arrays on top of each other or side by side. This is done by either hstack or vstack. Hstack, it returns a stacked array formed by stacking the arrays in the sequence horizontally, column-wise, while vstack returns a stacked array formed by stacking the arrays will be at least 2D in sequence vertically, row-wise. So hstack is column-wise while vstack is row-wise. We will see an examples. I imported NumPy as usual. We will then create a rank 1 in the array. X equal np.array 1 and 2. And then we will print x. And then we will create a rank 2 in the array. Y equal np array 3, 4, and 5 and 6. And print y. We will then stack x on top of y. We will put x in top of y, so it's a v stack. It's a row wise. We are creating a row. And then we will stack x on the right of y and reshape x in order to stack in the right of y, because here it's a row. We will reshape it to be a column, so it's h stack and then y x dot reshape 2 and 1, and we will print w. We will see this, and here is the result of our code. X 1 2 and y is 3 4 5 6. Z where we stacked x on top of y, here 1 2 x and then y. W where we stacked x besides y, and here it is. This is v stack and h stack. Also in the last video we talked about accessing elements individually. NumPy also provides a way to access subsets of ND arrays. This is known by slicing. Slicing is performed by combining indices with the colon symbol inside the square brackets. And there is three types or methods of slicing. There is start end, where we select elements between start and end indices, and there is a start colon. This select elements from the start index till the last index, and the last one is select elements from the first index till the end index. We will see an examples. Example 1, slicing in a 2D ND array. We will create a 4 multiply 5 array that contains integers from 0 to 19. np.arrange x equal np.arrange 20 and reshape 4 multiply 5. And we will print x. Then we will select all elements that are in the second through fourth row, and in the third to fifth column. This is method 1. We here specified an start and end and separated by a colon, as we saw here. Start, end, and separated by a colon. This is method 1. Then we will select the same elements as above using method 2, 1 till end, 1 colon. We specified only the start, and here by the first method. And then in the third, we will select all elements that are in the first through third rows and in the third to fifth column. Here we used method 3 and 1 because we here specified we didn't specify the start, but we specified the end, and then we specified start and end. Then we will select all elements in the third row, x2 colon, select all elements in the third column, colon 2, select all elements in the third column but return a rank 2 ND array, colon, comma, 2, colon 3. And these are the result. X here, sorry, X is the A range of 4 multiply 5 array from 0 to 19, 4 multiply 5, 4 rows and 5 columns. Z is the selection of all elements from the second through fourth row and third to fifth column, and these are the result of second through fourth row and from fifth to fourth column. Here, this is the second row to fourth and fifth to and third, to fifth column. W is the selection of all the same elements, 1 column and 2 to 5. It returned the same result, but in a different way. That's all. Y, here we selected from X from the start to the third row and from 2 to the fifth column. This is Y. Start to the fifth row. Start from the first through the third row and from the third to fourth column. This is Y. V, we only selected third row, and here is only the third row. Q, we selected elements in third column, and here they are. R, we selected the third column only, and here it is. In this example, we will use slicing and editing elements in 2D array. We will create a 4 multiply 5 ND array that contains integers from 0 to 19 using a range function, and we will reshape using reshape as a method, as we said. Select all elements that are in the second through fourth row and in the third through to fourth column. X 1 to 4 and 2 to 5, and then print Z. Change the last element. Here we only used slicing. Here we will use slicing and editing elements. And here, X from 0 to 19, Z we selected a specific part from the second to fourth row and from the third to fourth column. And here it is. We will change the last element in Z to 555. So we Z2 equal 555, and here it is. But we changed it in the main X, not in the Z. Okay, we changed it in the main X. Copy. This function creates a copy of the given ND array. This function can also be used as a method as the same way as we did in the last video by reshape function. We will see an example using copy function. Create a 4 multiply 5 ND array containing integers from 0 to 19 using a range function, and then create a copy of the slice using np function. np.copy, and here we are using copy as a function, and we inserted the slicing part we want by using the slice method. 1 to colon 4 and 2 colon 5. Then we will create a copy of the slice using copy as a method. We used first the slicing function x equal 1 to 4 column, and 2 colon 5. And then we used here copy as a method. Then we will change the last element in Z to 555. We will change the last element in W to 455, and we will print them all. And first, X from 0 to 19, the range we specified. Then we sliced, this is a copy here, we copy, we copied the same part, we copied of the slice using the NP function in Z here. Then we changed the last element in the copied part, and in W we create a copy of the slice here, and we changed the last element in W. So we can take a part from what we want and copy it and change it, while X will still as it is. After changing, X is as it is. This is the original X. This is X. After all we change it, it's the same because we copied a part of it in Z and W and changed the copied part. Okay, in this example, we will use ndarray as indices to make slices, select or change elements. We will create a range from 4 multiply 5, then create a 1D array that will serve as indices to select elements from X. So indices equal np.array from 1 to 3, and then we will print X. And then we will print indices, indices equal, and then indices. We will use the indices in the array to select the second and fourth row of X. We will use the indices we created to select specific parts of X. Y equal X indices column. And we will use the indices in the array to select the second and fourth row of X. X, Z equal X indices. And then X, this is the range from 0 to 19, and the indices equal 1 and 3. Y equal X indices from second to fourth row, and these are the indices of the second to fourth row. And Z, use the indices in the array to select second and fourth column of X, and here we used it to select second and fourth column of X. Diagonal is a built-in function in NumPy to select a specific elements in ND arrays. This function, it extracts or constructs the diagonal elements. Sometimes we want to specify to select a specific part of the ND array. So diagonal extracts or constructs the diagonal elements. There are three types. Where k equals 0, this is the default. It refers to the main diagonal. K greater than 0 used to select elements in diagonals above the main diagonal, while k less than 0 are used to select elements in diagonals below the main diagonal. In this example, here we will create a 4 multiply 5 in the array using a range function from 0 to integers, contains integers from 0 to 24, and reshape it to 5 multiply 5. Then we will print the elements in the main diagonal using z equal np dot diagonal, x from x. If you want the elements above the main diagonal, we will specify that k equal 1 where we set k greater than 0, here the diagonals above the main diagonal. And when we want to select elements below the main diagonal, so we will specify x equal -1. And this is the main x from 0 to 24. Z is the main diagonal 0, 6, 12, 18, 24. Y is the elements above the main diagonal 1, 7, 13, 19. W is the elements below the main diagonal 5, 11, 17, 23. Okay, sometimes we want to select or extract a unique element in the ND array. So this function np.unique returns the unique element in the given array. We will create a 3 multiply 3 ND array with repeated values. np.array 1, 2, 3, 5 to 8, 2 is repeated, and 1, 2, 3, 2, 1, 2, 3 are repeated. So in this, we only have 5 and 8 as unique. Print unique elements of x, np.unique x. That's it. The unique elements in x are 1, 2, 3, 5, 8. It returns all of them one time. 1, 2, 3, 5, 8. These are the unique elements. 1, 2, 3, 5, 8. It didn't return the multiplied or the doubled numbers. And this is all for this video, and thank you for listening.